welcome back.
Morning.
Hi. Last time we were together, we very briefly talked about this off camera. We talked about the absolute value function. This is what the parent looks like. So all the absolute value functions are going to be based off of this graph. And this graph looks like this. Only neater, because I clearly cannot draw straight lines today. Okay, and so the absolute value function, the parent of it looks like that. The vertex, the turnaround point is going to be at the origin, and then the slopes of these lines, it's going to look like a y equals x kind of line, and it's going to look like a y equals negative x kind of line. And so it's always going to look like this. Today, we're going to start our conversation with this thing. This is the general form of the absolute value function. And so what this form tells us is not only does it say, hey, it's an absolute value, so it's going to look like that V thing, but it's going to give us some information on a stretch, compression, or reflection. It's going to give us some information on any horizontal translations, as well as any vertical translations. And so that's the conversation today. I want to start with that A out in front, so I'm multiplying A to whatever's happening with the absolute value. And the thing that A controls is found on these three boxes right down here. So that's where we're going to start today. When that value A is bigger than 1, our function has undergone some sort of vertical stretch, meaning it's gotten narrower. So here's the parent function. This is what it looks like. And if I stick a number bigger than 1 in front of it, these things are going to push inwards. And so my graph looks like what I would hope I would look like after a diet. It's a little skinnier. If the value of A is some sort of fraction or decimal between 0 and 1, we've undergone some sort of vertical compression, and the graph appears to get wider. And so we're going to have something that looks like me after Turkey Day. It's a little bit fatter. Now if we've got a negative hanging out in front of the A, so it's like a -2 or -1/3 or something, we're going to have a reflection across the x-axis. So if this was our parent function with the reflection, it's going to look something like that. Next up, looking at the absolute value general form again, we notice this -h inside. The information that that part is controlling is going to be these first two boxes right here. And so that'll be the next thing we talk about. Both of these are some sort of horizontal shift. That means we're going to move either left or right. And the value that h is taking will tell us whether we're going left or right and by how far. If h is positive, that means you see absolute value of x plus some number. We're shifting it some units to the left. And so our graph is going to end up looking something like that. If h is negative, that means we've got x minus some number. Our function is shifting to the right, and so our graph is going to end up looking something like this. The last transformation that gets revealed under the general form is this plus k thing. And so the information for those is found in these two boxes right here. So we have the absolute value function, and then we're adding or subtracting some number at the end. That's going to control some sort of vertical shift. If it's positive, which means we see absolute value of stuff plus k, we're shifting up, and our graph ends up looking something like this. If it's negative, so we have absolute value of stuff minus a number, it's shifting down, and our function will look something like that. Ask me any questions you have on these items. It's going to stay the same size, yes. The only time we're changing sizes is if we have this value of a being something other than 1. Great question, thank you. Ask me one other question about this that you have. No other questions? Okay, so just that, just hers. Good. Now that we know where to move this thing around, notice how it's got this turnaround point? Like this spot where the graph literally just turns around and goes in a different direction. That spot is called the vertex, and it's going to happen at negative h, comma, k. And that negative h, comma, k is going to come straight from up here. Oh my goodness. Sorry about that. Okay. At that vertex, you'll find the minimum, the lowest, or the maximum, the highest point of this graph. And that will be where the range either begins, if it's the minimum, or where the range ends, if it's a maximum. And we'll see that in the next couple examples. We can draw the axis of symmetry, always going to be a vertical line with these guys. It's going to divide the graph into 2 equal pieces, and it always happens at the equation x equals whatever the x value of the vertex was. Notice that these two values are exactly the same. Okay? Don't overthink that one. That one's going to be the easy. Okay, let's draw a couple of graphs. I've got 3 versions here for you to look at. Which one would you like to see me start with? The last one? This one right here? Yes. All righty. I suspect you're picking this one because there's a lot of stuff happening. All right, so let's break this down. I see that this is an absolute value function because I have those vertical bars. That tells me this thing's going to look like a V. Everything else tells me what I'm going to do to the V to make it look different. This number out here is going to control either a stretch, a compression, and or a reflection. I don't see a number, so it's a 1, but I see a negative, and a negative tells me that we have a reflection. So we have a reflection across the x-axis. And then I'm looking for something inside here next to the x. I don't see anything, and so I have no horizontal translation, but I do have this number hanging out outside, which tells me I have a vertical shift, a vertical translation. What direction? With the vertical, your only directions are up and down. Down. Mm-hmm. How far? 2. Very good. All right. When I'm graphing these, I'm going to start left to right. So I'm going to do the reflection first, and then I'm going to graph the vertical shift second. And when I'm done, my final graph will get highlighted in green. All right, here is my parent function. And if I take a quick look at the homework, I notice that the parent functions aren't drawn for me, so I'm going to need to do that. These printed here are your parent functions, so you're welcome to just transfer them over to those graphs. All right, going to do reflection first. Now look at this point. How far away is that point from the x-axis? It's right on it. Trick question. It's not any distance, so I'm not going to do anything with that point. I'm just going to leave it right there. How far away is this point from the x-axis? It's this point? It's 1 unit, so from the x-axis in the opposite direction, I'm gonna go 1 unit, and I'm gonna place my new point there. I'm gonna repeat that thought process until I have enough points to know what this thing looks like. And I'd like to do it on both sides of the vertex in order to ensure that I'm drawing it in the right direction. Once I'm reasonably certain of what this thing looks like, I'm going to take a straight edge. I've got a classic ruler here, and I'm going to trace in, spin my paper so it's easier for me to trace it. There it is. So there's the first transformation. It's this reflection, and I'm going to call this reflection y prime. It's y because this is named y, and it's prime because it's the first thing that I've done to it. Now I'm going to look at y prime, and I'm going to do the second thing to it. So I'm going to end up with y double prime when I'm done. Okay, so I'm going to take the pink graph now, I'm going to ignore the black one, and I'm going to do a vertical shift down 2 units. So 1, 2, 1, 2, 1, 2, and I'm going to do this until I feel comfortable I know what the shape is. All right, I feel like I know what that shape is looking like. And I'm going to grab my straight edge, and I'm going to trace it out. Again, I need to turn my paper to make it easier for me to draw this.
I like those markers.
You like these markers? I got them at Target. Hashtag not sponsored. This is my final graph. There it is, and I'm going to call it y double prime because I had to do 2 transformations in order to get to it. From here, what is the vertex? It's that point right there. It's at -2, 0, -2 because I didn't move left or right. I just went down. Notice that this was the value of k. And we were told right here that the vertex is located at -h, comma, k. And here is k. And so my vertex keeps that value. I didn't have anything in here with the x, so I didn't have an h value, and so my h value was 0. Because I saw nothing there. We're all right with that so far? Cool. Last thing to say about this is my axis of symmetry. That's a vertical line that I can draw straight through the absolute value function, and if I were to fold it, it would land on top of itself. Because it's a straight line, its equation is always x equals something, and I don't have to think hard because once I have the vertex, I have the equation. Ask me 2 questions about this.
So if it doesn't have anything in front of the x, it's just 1.
Correct. If it doesn't have anything out here in front of the absolute value, we're going to assume that its values are 1. Great question. One more question about this, please. Even if you're worried it's too simple a question, you're welcome to ask it. None? She asked all the questions that were in your head. Good job. All right, let's talk about stating the vertex and axis of symmetry, but this time off of just the equation, no graph, okay? No picture, though you're welcome to later either graph it by hand or there's an app on your phone that you can get called Desmos, D-E-S-M-O-S, and a huge thank you to Jeff for showing me that app, D-E-S-M-O-S, Desmos. It's a fantastic app. It turns your phone basically into TI Inspire graphing calculator, and so it lets you graph all sorts of cool things. Or Desmos, D-E-S-M-O-S. It's for Android and Apple, both. You can find it, and it's a free download. So, hashtag not sponsored also. Thank you, Jeff, for showing me that app. I actually used it when I was grading some tests and quizzes. I graphed it real quick and compared what my phone said to what was on your papers. So that really helped make things quicker, so thank you. All right, so looking at this without the graph, I notice that I have nothing in front of the absolute value, so I'm not going to have any sort of stretch or compress or anything. I notice that inside the absolute value next to the x, I have something. This is the value of h. And then outside of the absolute value, I have something. This is the value of k. According to my notes above, the location of the vertex is at negative h, comma k. All right, what is the value of h? Negative 10. I want a negative 10. So a positive 10. Two negatives next to each other becomes a positive. A negative 10 is the same as just a positive 10. K. I want just k. What is the value for just k?
8.
Very good. And so my vertex is located at the point 10, 8. If you were to graph this one, you should see that vertex happening at 10, 8. Next thing up is the axis of symmetry. Please remember, axis of symmetry is a vertical line, so it is always x equals something. And I heard someone say 10 because she looked at the x coordinate of the vertex, and that's exactly where the axis of symmetry lies. Can I have 2 questions about this item, please? None because it was explained that well?
Yeah.
I rock! Nice. That's, whew. I have one last thing to say, and that's domain and range. So let's come back up to the graph that I did originally, and let's add in a section for domain and a section for range. What did domain mean again?
The x.
Correct, all of the values that x could take. So if I look at just the green graph, because remember that was our final transformation, the green graph. What are all the possible x values for the green graph?
0.
It could be 0, you're right. What else could it be? All of them. All of the numbers. Yes, and so she's tracing with her pen very carefully in the arrow symbol that looks like this, which is our symbol for all real numbers. I will also accept the interval notation if you want to write it this way. I will also accept you actually writing it all out and saying all real numbers. That would make me happy as well. Whatever feels like the least amount of work for you in that moment is completely okay with me. Let's talk range. Does this have a maximum or a minimum?
Maximum.
Maximum because it's pointing downward. What is the maximum value this thing can take? -2. And so my range is going to end at -2 because that is the maximum value that this could be. What's the minimum value this could take? -infinity because I have these arrows on the end, meaning it's just going to keep dropping, and so I'm going to put a range of -infinity. I can't include -infinity because it's a thought, not a number. If you wanted to write it in inequality notation, it would look something like this. And if you wanted to write out in words, you would write all numbers less than or equal to -2. And again, happy with whichever one of these that you like the best, that makes the most sense to your head in the moment. Ask me 2 questions about the range and the domain, please. 2 questions about domain and range. All right. 2 questions about anything overall. None because I'm a rock star and did it right the first time. Thank God. All right, that's all I had for you guys today. Thank you so much.